So what we discussed yesterday, let's have a quick recap of that, and then we'll see what we are going to discuss today. Okay. So yesterday we had discussed about the security policies, right? Security zones, uh, what kind of zones are there? Not exactly what kind of zones, but what a zone is, right? I have mentioned yesterday that we'll be discussing about types of interfaces and those layer 3, layer 2, and those kind of things today. And we have discussed about the security policies, wherein what is the significance of a security policy, how we can create a security policy to allow a traffic. There are two default rules or policies already existing on the Palo Alto firewall that we cannot delete, right? The first one is intrazone allow, the second one is interzone deny. I have explained the difference between intrazone and interzone. So intrazone uh, means coming from a zone and going to the same zone, right? So the traffic originates from one zone and then headed back to the same zone. That kind of traffic is called as intrazone, and the interzone is originating from one zone and heading towards second zone or a different zone from where it originated is called as interzone. Now, intrazone is allow by default and interzone is deny by default, right? Uh, Subhash, I think you can check your audio because I got a confirmation from a lot of guys that the audio is clear. Okay. All right. So we discussed about these default rules. We then tested the connectivity from one of the client machine, which is there in the trust zone, right? So uh, we assign an IP address as 172.16.1.2/24 to this client machine, and then we tried to ping google.com. Initially it was not working. We then create It was not working because this traffic was interzone traffic, right? Interzone because it originated from trust and it was headed towards untrust, right? So we then created a security rule that was allow internet, uh, which allowed the traffic from trust to untrust, right? This rule was a broad rule. We have not specified any granularities as to what will be the source address, what will be the destination address. We have just specified the zones, right? That any traffic originating from trust heading towards untrust would be allowed, right? So any traffic, it could be Bob, could be Steve, any other PC which is there in the trust zone, will be able to reach out to the internet, right? Or to be precise, in will be reach out to the resources in untrust zone. Okay. Uh, Cool. So yesterday we were in a situation because let me bring the course content. All right. So we have completed till this point, that is security policy between zones, right? Now, because there is one important topic that I'd like to add is interface management, interface management profile. Now we were, it was getting difficult to demonstrate the intrazone traffic because we cannot have a traffic generally. I mean, we can ping the default gateway, but it will not give the reply, right? So we will see why that is the case, and why we were not able to, verify this gateway yesterday, right? So we will see this interface management profile. What is this? What is the use of this interface management profile? We'll quickly review the intrazone traffic, right? And then we'll go ahead with dynamic NAT with port numbers or DIPP. That's what we call it in Palo Alto. We'll have a look at the static NAT and we'll have to will try to cover application filter in today's class, right? So I mean, I would say this is really important. This is where it gets interesting, because these are the things which really, you're going to go ahead and deploy in the corporate environment. Initial config is most of the time you'll see that they are already in place, right? Uh, Rarely you go, unless it is a new firewall, you rarely go and deploy it, right? So if a firewall already exists in the environment, these would be the changes that you might have to go ahead and create a security rule. You might have to go ahead and create a NAT rule, right? And then what kind of NATs we need to create, and then do we need to add any granularity uh, by adding certain applications, right, to that rule. Okay, so we will also see applications and application filter. Okay, okay, so let's get started. I'll just give you a brief overview what we are going to do so that we can quickly jump into the labs. Okay, uh, let me go back to the diagram we had yesterday. Okay, so this is the reference diagram that we were using. Let me clear it out a bit so that it is more readable. Okay, so uh, today, uh, in order to check the interface management profile, so what exactly is an interface management profile, right? Let's talk about that. So interface management profile. Okay. So what happens is we generally have a management interface, right? There would be a management interface from where you will connect a out of band management PC and or a desktop laptop, whatever you'd like to call it, and you'll be able to access the management of this firewall, right, or the GUI of this firewall, right? Now, what happens is there might be a requirement wherein you might have to access these services from the data plane interfaces as well, right? Uh, what could be these services? For example, you want the HTTPS access of this firewall. That is the GUI access of the firewall using the data plane interface, okay, not the management. So management is by default, it has it, right? We are talking about these Ethernet 1/1, 1/3, these interfaces. Using these interfaces, if you'd like to access the GUI or HTTPS access of this firewall, we can do that using interface management profile. If you'd like to have the HTTP access, right? So the difference between them is that HTTPS is secure, HTTP is not. So if you'd like to have an HTTP access of the firewall, you can. Now, if you would like to ping this interface, now by default, everything is denied on the firewall, right? That we have already seen because of the interzone deny, right? Uh, However, if you'd like to sort of like if you do a ping, for example, Bob wants to ping the default gateway, that is 172.16.1.1, which is on the firewall. If I will do it right now, we'll not get any replies back, right? Because this interface is not configured to reply back to the ping request, right? How we can do that? We can enable this using interface management profile and selecting ping. Okay, ping. You can also enable telnet. You can also enable user ID, right? And there are other features that we can go ahead and uh, enable using SSH, right? We can go ahead and enable using interface management profile, right? Uh, SNMP. There's one more important SNMP, right? So this interface management profile allows this data plane interface to enable these services on that particular data plane interface, right? Now, if we enable interface management profile on Ethernet 1/3 and enable ping, and when Bob pings the default gateway 172.16.1.1, it will get a reply, right? Then again, we need to understand this is per interface basis configuration, that we can configure a profile and then those profiles are applied to the individual interfaces, right? So right now we have two interfaces. Okay, let's go ahead and check this particular configuration. I mean, there's nothing much to discuss about this. I have already explained it. Let's go ahead and have a look at the lab and see how this works. Okay, so so again, we were not able to see the logs, traffic logs yesterday. I have updated the lab 3 right now. Let me close this and we'll navigate back. So if you come here, you'll be able to see the lab 3. I have updated this lab 3. If you open this, you will be able to import config. So this config, okay, it has some config. Let me wipe it out. Yes. So I wiped it out. Let me do an import. Okay, right. So the import was successful. Let's go ahead and start this machine, this, my management PC and my ISP router. Okay. So once you import the configuration on this firewall, you'll be able to see whatever configurations that we have done yesterday are present over there. So first was security rule. The other one was the NAT rule. I did not discuss much about the NAT yesterday. I just gave you uh, a brief as to why a NAT would be needed. Because the return path, and again, there are multiple use cases, not just the return path, right? It's wherein you'll hide your private IP addresses. The IP addresses, private IP addresses, are not routable onto the internet, so we use NAT so that we will be able to reach out to the services on the internet. Uh, a lot many things, right? So the IPv4 pool, global pool that is globally available is about to exhaust. So we use NAT, wherein private IP addresses would be used in your corporate resources, and when you go out to the internet, you will be using the public IPv4 IP addresses, right? And that's possible by use of NAT. So it helped to elongate or extend the use of IPv4, right? Still, they are on the verge of exhaustion, but still, NAT allowed us to go on with IPv4 for some time longer. We already have IP6, but yeah. Uh, oh, mm, Not able to log into. Mukundan will see that. Okay, no worries. Kali Vignesh, voice is not audible. Guys, my voice is not audible. I mean, can you guys please confirm? Okay, Jayakumar says clear for me. It's okay. All right. Okay. Guys, I mean, those who are facing the challenges with audio, I guess either they can drop and connect back. There might be some issue with the audio. All right. Okay. Thank you, guys. Thank you for the confirmation. All right. Okay. So, all right. We discussed about the NAT, right? Now let's go ahead and start my management PC. So we can see the PC is up. Let me check the IP address. So for me, it's there because I did not wipe my node. Uh, if it is not there for you, all you have to do is just assign an IP address that is 192.168.1.2. Okay. I think that's not a very big task. So that could be done manually. Uh, let's see if our firewall is booted up or not. Okay. So we see a PAVM login prompt. Let's see if we are able to log in or not. Admin test at 123. So I'm able to log in, and please, once you import, you need to use the password test at 123. Okay. Uh, the default would not work if you import it because it already has the configuration where we change the password to test at 123. Okay. So once you import, make sure you are using these credentials, which are already mentioned over here. Okay. These will only work. All right. Uh, cool. Let's check the IP address if it is there or not. Show system info. This command will give you the information about your firewall. So we can see the IP address is 192.168.1.1, and the mask is 255.255.255.0, right? So let's go ahead and see if we are able to access this firewall from the uh, web browser. https://192.168.1.1. Now, one thing to note that we are right now accessing this firewall from management interface, right? So you see this is the management interface. We'll see how this interface management profile can help us. Okay. So let's go ahead and log into the firewall. Admin test at 123. Allow it a minute to load. In the meantime, let's check this Windows machine if it has IP address or not. I believe for me it should be because I have not wiped my node. If in case you don't see the IP address, assigning IP address is not really big task, so I have not created the config backup for those. You can simply go ahead and assign the IP addresses, right? Uh, IPv4 properties. So I have already the IP address assigned 172.16.1.2. This is my Windows machine on the LAN segment. Okay. And default gateway is 172.16.1.1, which is the IP address on the trust interface or Ethernet 1/3 interface of this PaloAlto firewall, right? So this machine has 172.16.1.2. This interface has 172.16.1.1. So the default gateway for this machine is this particular interface. Okay. All right. So our firewall is accessible via GUI. Let's go ahead to network tab. We'll directly jump into the configuration part. Under network tab, if you see there are network profiles that you can see, and once under network profile, you'll be able to see the interface management. Okay. Now we need to click on add. You can give it any name that you want. I'll give sorry, allow ping. Okay. Because I'm just going to enable. ping as of now. So you can see there are administrative management services like HTTP, HTTPS, Telnet, SSH, right? Telnet and HTTP are not secure. HTTPS is the secure method of accessing the firewall on a web browser, and SSH is again, you can use any SSH client like PuTTY to access the CLI of this particular firewall. Okay, so as of now, I don't need these two to be enabled, or for good, let's go ahead and enable these. Okay, so I'm enabling HTTPS and SSH, and also enabling ping. Under network services, you'll be able to see something called as ping, HTTP, OCSP. OCSP is is used to validate if a certificate is still valid or not. Uh, if the certificate is revoked, so this is related to PKI. SNMP is network monitoring protocol that you can use to get the information from the firewall. What is happening? Tunnels are up, interfaces are up or down, right? So get the status from the firewall. Response pages, user ID, there are multiple options, really not in the scope to discuss. Okay. And there is something called as permitted IP addresses. Permitted IP addresses is nothing but an ACL, right? So if you go ahead and enable or configure this interface management profile, and you will be able to add, if you want that only certain IP addresses would be able to access these services, then you can add the IP address over here. For example, whatever machine address, so I my this machine has 172.16.1.2. I just want these services to be accessible from this Windows machine only. Okay. In that case, I'll go ahead and add this permitted IP address 172.16.1.2, and then I'll be able to reach out to the interface wherever I assign this profile. As of now, I just gave you an idea. This is simply an ACL access control list. Based on this, the IP addresses which are mentioned over here will be able to access these services that I have checked over here on the interface where this profile will be applied. Okay, let's click on OK. Now let's go to our interfaces, Ethernet. Now you see there are two interfaces. Generally, it's not a good idea to allow pings or HTTPS access to your ISP interfaces, right? So our Ethernet 1/1 is connected to ISP. So generally, it's not a good idea. It will give you a warning as well. Okay. Uh, as of now, we are gonna apply the interface management profile to Ethernet 1/3, which is my, uh, if you see, is zone is trust, right? So let's go ahead and uh, apply this advanced management profile, allow ping, right? So this is where you have to navigate to the advanced tab, and you'll be able to see management profile, where, in the drop down, you'll be able to select the management profile or interface management profile that you have configured. Okay. So you don't need to play with any other options over here. These options might sometimes break your environment if you're not familiar with that. So I'll recommend just stick to what we are doing. Okay. Uh, Click on OK. See, it gave you a warning, right? By attaching this interface management profile to this interface, you are potentially exposing the firewall's administrative interface to any party that can reach this interface. So, one important point to note is that any party that can reach this interface, right? So, that is one important point that we should keep into consideration, right? So, right now, this Windows machine should be able to reach dot one because they are almost directly connected, right? All right, let's go ahead and do a commit. Meanwhile, this commit goes through. Let's come back to our security policies. So these are the exact same rules that we have created yesterday. Okay. Let me go ahead and, okay, let this commit finish first. So meanwhile, this commits, I'll close this. You can simply close this, and then you can review the progress going to navigating to tasks, and then you'll be able to see your commit job over here. 0%, right? It is progressing. You'll be able to see the progress here. And this is the auto commit that I have already talked whenever you boot the VM or physical firewalls, there will be an auto commit job that gets triggered. Okay. So this is the security rule that we have created yesterday. Allow internet from trust to untrust, and we have set this as application default, right? And the action right now is allow. Okay. Uh, we have configured the NAT rule. This NAT rule was to allow the NAT the traffic which is coming from trust heading towards untrust, and then we are NATing it to the interface Ethernet 1/1. 10.11.2 is the IP which is being assigned to this particular interface, right? And we are doing PAT. Okay, so let's see if the commit is successful. Right. So we can see the commit status completed. You can click on this. You can, it will say configuration committed successfully, right? Let's click on that. Uh, let's close this. Now let's go to the, this is the Windows machine, right? Which is having an IP address of 1.2. That is Bob. Okay. Uh, there are two things that I'd like to check as of now. The first thing is whether I am able to ping. Okay. Uh, I would like to demonstrate you the intrazone traffic as well. So let me first override these. So by default, these rules do not log the traffic. Okay. In order for these traffic to log, in order for these rules to log the traffic, we'll have to override them. That we have already seen. Log at session end. Click on OK. Intrazone default. Override. Actions. Log at session end. Click on OK. We'll have to do another commit. Vignesh, is on the same subnet LAN and firewall trust. Will it not ping by default? Uh, they will ping, but the firewall's behavior is that it will not reply to anything on its own, right? So we need to uh, explicitly configure it, right? We need to explicitly tell it, okay, on this interface, if you receive a ping, then you should reply it. Okay. So that's what we are doing over here. We are trying to uh, you know, add that interface management profile so that the ping replies are being received. Okay, let's that I believe that's almost done. Okay, so this configuration is committed. Let's go ahead and first let's try to ping 172.16.1.1, right? So it's able to ping. Okay, we are able to reach our next hop, that is the PaloAlto firewall. Let's see if we are able to access that firewall as well. So HTTPS colon forward slash 192. Sorry, now the IP address will be the interface IP address 172.16.1.1. Enter. Now you can see it's loading, right? So we are able to access the firewall's GUI, but you will see that it is not the management interface IP address. The IP address that we are using is the data plane IP address, right? The IP address which is assigned to this interface Ethernet 1/3 172.16.1.1. Cool. This is because we have enabled the interface management profile on this interface where we have checked the option of HTTPS, SSH, and ping. Okay, let's see if we are able to log in. Admin test at 123. Log in, right? So this is working. We are able to log in. Okay. In the meantime, let's see if we are able to do SSH, because we have enabled SSH, right? Let's try to do a putty. While trying this in your lab, guys, please be mindful that you're using the interface's IP address. Don't try to use the management interface IP address when trying to access it from the LAN PC, because that will not work, right? As we have discussed, management plane and data plane are separate. You'll not be able to access that. Okay, we are able to access the the GUI and the CLI right now because of the interface management profile. Okay, uh, click on open. Let's see if you get the prompt. It says it gave you a warning, and then you're able to see login as, right. So admin and then test at 123. Great, there we go, right? So we are able to access the firewall CLI and GUI using the interface management profile, and we are able to access this from the data plane interface, right? So this makes it more simpler and easier to manage at times, but however, we should be very careful while allowing this access, right? We should definitely use permitted IP addresses. This is just a lab, so I'm not using any permitted IP addresses, but in the corporate environment, it is always recommended that you have the security measures in place where there are permitted IP addresses being used, so that you are able to restrict the access, who is able to get the GUI and the SSH access of the firewall, right? Cool. So now, yeah, you can view the logs directly from here. If you come here, you'll be able to see the traffic uh, originating from trust heading towards trust, right? So the from zone and to zone is same, right? And the source is 172.16.1.2, that is my Windows machine. And the destination is 172.16.1.1, which is the interface on the firewall, right? You can see the port is 443 because we are trying to access the HTTPS GUI access of the firewall. The action is allow, and you can see the rule that is allowing it is intrazone default, right? That's what we have discussed earlier. Cool. If you want to see more details of the logs, you can just simply come here, click on the glass icon. This will show you the details, a lot more details over here. Let's give it a minute. It's still opening. Yes, Manny, it's advisable uh, generally to use it in out of band management access only, right? So CLI and HTTPS generally should be uh, out of band, but there might be some requirement wherein you might have to do it. Okay. So cool. You see, this is the detailed log view. You are able to view the information about the session, what was the action that was taken on this traffic, action sources from policy, which policy. So this is the rule, right? Intrazone default. What is the application that was identified? It is SSL, right? Because SSL is encrypted. Whatever traffic you see as HTTPS will be identified as SSL because the traffic is encrypted, right? In order to understand what is the actual application going inside that SSL tunnel, we need to do something called as decryption. However, that is not in the scope of this bootcamp, but it's a good thing to know that there is something called as decryption, wherein you can decrypt the HTTPS traffic and do the inspection, to understand what's actually what application is actually traversing inside that SSL. Okay. Uh, we can see the source user, we can see the source zone, the interface on which the traffic was received, and then this is the destination tab where you see we are not using any user ID, so you're not able to see any source user and these kind of information. The destination was the interface on the firewall, the port that it was trying to access 443. Again, the zone is same trust, and the interface is 1/3 from where the traffic went back, right? You can see the information like bytes received, bytes sent, what how many packets were uh, uh, received, total bytes, right? Total packets were 14, packets received, packets sent. Uh, what is the application category? What technology it's being using. So you'll be able to see a lot of details over here. Okay, if you would like to get the detailed log, all you need to do is just click on this glass icon, and this is how your intrazone rule actually works. Cool. All right. Uh, let's go back to the topics. So, mm, 1 second. Right? So, this covers the interface management profile and how your intrazone traffic actually works. Uh, let's have a quick review. If we have some traffic, definitely we should have some traffic towards the internet as well. So, if you see this traffic over here, and now you'll be able to see the traffic logs. Okay, so you will all of you guys will also have these traffic logs under monitor and traffic. So in order to access the traffic logs, just click on monitor, navigate to logs and traffic, and you'll be able to see the traffic logs. Okay, so this traffic, I just wanted to have a quick look at the traffic which is headed towards the internet, right? um, Give it a minute. All right, the differences, if you see the source is again 172.16.1.2. That is the Windows machine on which we are logged in right now. You can see the zone where the traffic originator is trust. Interface is Ethernet 1/3. The Now we are doing a source NAT, right? If you remember, yesterday we have configured a NAT rule, default NAT, right? So it's NATing the IP address to 10.1.1.2, which is the Ethernet 1/1 IP address, right? And then this is the NAT port. Now this is because source NAT, so uh, it would be to a random port because we are doing DIPP. We'll discuss about this NATing today. The destination is internet, right? Because this is a public IP. It gives you the information about the country. It gives you, now you can see this country, it says 172.16.0.0 till 31.255.255, because this is a private IP address, right? It does not belong to any country. It's RFC 1918 uh, IP addresses that anyone can use in their internal environment. And this IP address is a publicly routable IP address. So the country, it belongs to the country United States. The zone is Antrust, and the interface is Ethernet 1/1. The NAT IP, I mean, we are not doing any destination NAT, so the destination is going to be the exactly same, and the port is going to be the same. So the NAT is not applied over here because you see this, the IP address is the exactly same to the destination that we are trying to reach. You can see the IP address over here was original IP address is 172.16.1.2, and the translated IP address is 10.1.1.2. Okay, so this is what I wanted to show for the NAT part. Let's jump into the practical for the NAT rules now, because we have already had a discussion. What NAT, what NATing is. Okay, so I'm just going to go ahead and discuss about the NAT rule configurations and how we can, what type of NATs we can actually configure. We are not going to do any DNATs over here because DNAT, I think there are a lot of beginners in the class, and DNAT might be a bit of like, difficult to understand at this point in time. Okay. Uh, right. Let's get into the NAT configuration. Let me close this. Okay. I would like to, or I would prefer to, access the CLI or GUI from the management. Uh, that is this out of band management PC. Okay. Let me minimize this. All right. So this is the security rule that we have configured, and let's check the NAT rule that is already in place. Okay. So let's review this NAT rule that we have configured. We have configured a default NAT. That means it's just the name. Okay, it does not mean anything, but we'll see what parameters it's going to look into to enforce this NAT. Okay, on the NAT policy rule tab, you'll be able to see these general parameters like the name. You can give a description to the NAT rule. I mean, it could be a simple description, right? Going to a web server, going to internet, or whatever that gives you an idea as to why this NAT rule was configured in the first place, right? You can assign tags. Tags are generally a way to organize your rules, right? So, for example, to certain destinations, you'd like to do a different kind of NAT, and then to your public internet, you'd like to use a different kind of NAT, right? So you can just attach the tags to all the rules that perform similar kind of action, and then based on these tags, you'll be able to filter them out. So it's just a means of organizing and visibility, nothing too much onto the functionality of the NAT itself. Okay. Group rules by tag again, the same thing, right? If you'd like to group the rules and okay, these four rules are for web servers, and these four rules are internet, these four rules are maybe to the internal server, right? So you can group them. NAT type, there are three options over here. You'll be able to see IPv4, NAT64, and NPTV6, right? Generally, you don't have to worry about these two. We are going to do IPv4 only in our lab. But for the sake of understanding, NAT64 is used when you have disparate systems. What do we mean by disparate systems? That means some part of your organization is using IPv4, some part of your organization is using IPv6, and the translation is to be done from IPv6 to IPv4 or IPv4 to IPv6. In that case, we use NAT64. NPTV6 is used when you'd like to do a NATing for IPv6 address, right? So from IPv6 to IPv6, you're going to use NPTV6. Okay. Anyways, we are not going to touch on these. This was just for the information. So the NAT type, we are going to select over here as IPv4. Audit comment, I have already mentioned, audit comments are being used by the internal auditors of your organization, or maybe the compliance authorities that they'd like to review what changes were done at what point in time. So audit comments would specify, like, for example, created this rule on this date at this time to allow access to internet. Click on OK. Now, next time you modify, you come and add this audit comment again. Modify this rule at this date and this time to create exception for this particular user, right? So this gives you an audit trail to understand what changes were made at what point in time, so that your auditors will be able to understand why these changes are there in the system. Okay. Uh, Original packet. So original packet is the packet that arrives at the firewall. Okay. Uh, the traffic that originated, we just saw, right? We saw the traffic going to the internet. We saw the traffic originated from trust because the packet was coming from Bob, that the IP address was 172.16.1.2. So that means what? The traffic originated from the zone trust. Okay. So we have added the source zone as trust. Okay. Destination zone is the destination zone where the packet is supposed to go, right? Now we'll talk about this lookup, how this happens, and how but you will know, right? Because you want to send the traffic to internets, and the interface that is connected to ISP is Ethernet 1/1, right? So you will be aware about the zone that is assigned to Ethernet 1/1. So the destination zone over here is untrust. Okay. And then you can also filter based on the destination interface. So you'll be able to select your interfaces that are configured based on the interface to which you would like to, based on the interface, when the lookup happens, based on which interface it is supposed to go. So the destination interface, right? And then service. I have already discussed on this. Service is nothing but ports on the PaloAlto firewall, right? So if you'd like to do the NATing only for the traffic coming on port, for port 443, right? So in that case, what you'll do, you'll select service as HTTP or HTTPS, okay? Or HTTPS is port 443. If you'd like to do NATing for any other ports, then you can create a new service, right? These parameters, right, when you say original packet, are the parameters that it will match to the packet when it arrives at the firewall. Okay. You can specify the source address. I can add the IP address as 172.16.1.2 so that this NAT only takes hit for Bob. So let's do that. Okay, let's build this granular 1.2. Okay. So I added the source address as 172.16.1.2. Okay. And I am not concerned about the destination address. Let it be, so it's going to Untrust definitely. That means it's going to internet. There is no particular IP address destination that I'd like to add over here. Okay. So let this be selected as any uh, destination which is there on the internet. Okay. Translated packet. Now, this is the interesting part or the important part that we are going to discuss. We are going to discuss about the source address translations only. Destinations, DNAT is really, I think it's complicated. And again, this is not in the scope of this bootcamp, right? Uh, Guys, we'll answer the questions towards the end of the class, right? Because answering in between will disturb the flow. Okay. Cool. So the translated packet is the packet, is the information based on which you'd like to translate the packet, right? So, for example, based on let's say there is a packet which is coming from Bob heading towards internet, and it is matching these parameters, right? Now, so the original packet match. So this NAT rule should take a hit. What changes will be done? The changes will be done based on the configuration that we do under the translated packet. Okay. So we are configuring for source address translation. Source address translation is uh, right now it's selected as dynamic IP and port. There will be, you see, there are actually three IPs and then there is none. Okay. Sorry, there are three options and then there is a fourth option that is none. So none is selected when you don't want to do any NAT, right? Or in simple terms, it's called as no NAT. Okay. If you'd like to configure no NAT, then you go ahead and configure this rule. Now, why would you like to do that? Uh, there are certain use cases wherein you might be doing a NAT for a subnet, for example, 172.16.1.0/24. However, there is one particular IP address, 172.16.1.100, for which I don't want this NAT to be applied. Okay. So what I do, the NAT rule is created for that subnet. However, I create a no NAT rule above that saying that whenever you see a packet from 172.16.1.100, do nothing, right? So none will be selected there. So that's how you configure no NAT. Okay. So the point of interest for us is dynamic IP and port, dynamic IP and static IP. So let's go to the whiteboard and understand what these three options are. Okay. Dynamic IP and port, dynamic IP and static IP. Just give me a second, guys. All right. So there are three types of source NAT, right? The first one is DIPP, n- dynamic IP and port. Okay. The second one is dynamic IP. The third one is static IP. Okay. Now, again, the NAT rules follow the same approach like the security rules. Okay. What do we mean by that? It means that it will always be evaluated in a top-down approach. Okay. Evaluated in a top-down manner. Okay. So whatever rule matches the packet and takes a hit, the NAT lookup stops there. Okay. So let's say you have 100 rules. There is a packet that arrives at the firewall. The firewall started the NAT policy match, and the policy was matched at, like, let's say 50th rule, right? So that NAT policy will be evaluated, the translations will be done, and that NAT lookup do not proceeds further to 50. It stops there. Okay. So it's evaluated in a top-down manner, exactly similar to your security rule. Okay. Now, DIPP is nothing but PAT. Okay. So port address translation. Okay. Wherein you can use the simplest configuration that we already have on our firewall is wherein you can use Ethernet interface IP address. Okay. And port. Right. So for example, let's say there is a packet. Okay. All right. So let's say there is a packet that comes at that originates from 172.16.1.2. Okay. And headed towards this is my source IP, and it is headed towards 170. Let it be, let's say, any IP. Let's say 100.10.10.10. Okay. This is the destination IP. Okay. The source port, as we all know, would be an random port number that will be assigned by your so this will be your source port. So source port is, let's say, anything, let's say 65,000 for simplicity. And the destination port is going to be, let's say, 443. Okay. So this is, let's say, this is the packet that arrives at the firewall. Okay. This packet, when the firewall sees it, and it will do a what all things will happen when the firewall first sees this packet, right? So there will be some lookups that will happen. So the first lookup that happens is route lookup. Okay. Based on the route lookup, we'll be able to understand the egress interface and zone, right? Route lookup, again, this is the networking concept. Not going too much deep into this. Route lookup is wherein a packet comes, so it will check how to route or how to reach to this destination IP, right? So there will be certain routes on the firewall, or the virtual router rather. It will try to see if there is a destination matching this. Right now, we have a default rule that is configured, right? So based on that route lookup, it will determine the egress interface. Like, what do you mean by egress interface? From where to send the packet, right? And then that interface will also have a zone, right? So this will give you the information about egress interface and the egress zone. Okay. So route lookup, once route lookup happens, we'll do a NAT lookup. Okay. So NAT lookup will evaluate your NAT policies. Okay. And then there will be a security policy lookup. Okay. So security policy lookup uh, evaluates your security policy. There is entire life of a packet diagram, guys, that you can refer, which is available on the internet. Okay. How, again, discussing that would take up too much time and not feasible as well, and not in the scope for the boot camp. This is the very simplified way of, if you go onto the internet and do a life of a packet Palo Alto search, you will be able to get a diagram. And in that, you'll be able to see there is a slow path section. So this is just where the lookups happen. Okay. So this is the very simplified version of that. Route lookup, again, wherein we understand how are we going to route to this particular destination. NAT lookup is going to check against all the NAT policies, and security policy lookup is check if there is a security policy that allows the flow. Okay. Now, what we need to understand is uh, security policy should always be configured in a way wherein the post NAT zones, right, should be reflected or should be allowed. Okay. What do I mean by this post NAT zones? So when the packet arrived, we had a certain egress interface and zone lookup and everything was done. And then we did, if there is a NAT policy that matches that, and then we evaluated the NAT rule and then we translated the packet. After translating the packet, we need to understand, right, again, how we are gonna send the packet, right? So there is a possibility after you apply the NAT rule that destination that zone might change. Okay, so the security policy should be always configured in a way wherein the post NAT zones should be allowed. Okay, what do I mean by that? So let's see, what is the source zone for this traffic? The source zone for this traffic is right now trust. The destination zone for this traffic is untrust. Okay. Now let's say we have configured it to do a source NAT. Okay. The source NAT is gonna change this particular IP address into the public IP, or the interface IP address of Ethernet 1/1. Okay. So we are gonna do a SNAT, source NAT, right? And that will also now, that is where the IP address are being changed, and we are doing a PAT. Remember, we are doing a PAT. So in PAT, we are also going to change the port number, right? So the SNAT is going to modify these two values based on the DIPP. We have selected what DIPP, which is doing, which is similar to PAT. So it will modify your source IP and the port address to reflect the interface IP address on Ethernet 1/1. Okay, what we have configured on Ethernet 1/1. Okay, so let's say the NAT translated packet. Let me move it a bit. Now, that was the original packet. Now let's talk about the NAT translated packet. The NAT translated packet will be, so the interface IP, the source will change to 10.1.1.2 because that is the IP address which is assigned to your Ethernet 1/1. The destination is still gonna be 100.10.10.10. We are not modifying the destination address. Okay, this is my new source IP after NAT, and this is my same destination IP after NAT. Okay, and then my source port originally was 65,000. Now because I'm doing a PAT, I'll modify it to some value, let's say 23,000. Just for an example. Okay, this is random. Don't worry how this 23,000 came. Okay, so source port, and then we have destination port. The destination port is still gonna be 443. Okay, because we are not doing anything to the destination, we are just doing a source NAT. So this particular piece of information and this particular piece of information will be modified based on the NAT. Okay, now if you see, uh in order for this traffic to go through, we need to understand if there is any change on the, if the zones have changed after the NAT being applied. Okay, now uh, uh, let's verify the traffic. Right now, the traffic would be, if you see, this is going to be your untrust. This is going to be your untrust, and these port numbers are not required, right? So actually, we are able to see that the port, the destination. Sorry, my bad. What I'm doing, my bad. Has there been any change to the destination? No, right? So what is the postnet zone when you do a lookup? The lookup is always done based on the destination. So what is the lookup? What is the destination zone? Untrust. Okay. So the destination remains unchanged, right? So should this take a hit on our security rule, which we configured in the first place? Allow internet. Allow internet has the source as trust and destination as untrust, right? And the action over there is allow, right? Will it take a hit? Let's go ahead and check that. Okay. So if you see, we already have a traffic in place, right, which is heading towards the internet. Let's generate few. Let's generate some more traffic so that we'll be able to see if which rule is taking a hit and which rule is uh, doing the NAT. Okay. So we are able to access the internet. That means we are able to reach to the internet. Okay. Let's minimize this. Let's head to the monitor traffic logs and let's see if we are able to see the destination. Now we see the destination as 142, 250, 195, 206. This is the uh, traffic heading towards the internet. Let me open this. So once we see the detailed log view, right, you'll be able to see what's happening with the traffic, right? We have already discussed this. Now you see the rule that it's taking a hit is allow internet, right? And you'll be able to see that the NAT that is happening over here, it's taking the NAT IP of this 10112 and the NAT port is 46728. Okay. So the reason for this is the destination is not changed. We are not doing anything on the DNAT. So that's the reason it's we're not doing anything any changes on the destination. So that's the reason you are able to see that the same security rule is taking the hit, right? Because this is allowing the traffic from trust to untrust. Okay. Let's take the NAT rule. Let me do one thing. Let me reset the hit count so we'll be able to see that this is actually taking all rules. Yes. So resetting the hit count will make everything as zero, as if like this tool has never taken a hit. Let's go ahead and initiate the traffic once again. Okay. Let's see if there is a hit. We can see there are 21 hits. So this rule is taking a hit, right? Wherein the original traffic originated from trust headed towards untrust, and we are right now doing a DIPP. Okay. Uh, you can see the information over here. Dynamic IP and port Ethernet 1/1 10.112/24. Okay. Uh, Now you would say, Amol, what is so significant? You mentioned over here that post NAT zones should be allowed. Okay. Why? So right now we are doing a source NAT, right? Source NAT is not affecting the destination where this traffic is being headed. Okay. But because the route lookup is going to be the same, so the destination, the egress, if you see, we have mentioned over here, is the route lookup is to determine the egress interface and the zone, right? So here there is no change of the destination, right? So the destination zone remains the same. The traffic rule is taking the hit. That's absolutely fine. The challenge would come when there would be a destination NAT. Again, destination NAT is not in the scope, but I'll just give you a brief explanation, a very simple explanation. So if this is my PA firewall and this is the public interface, let's say this is your internet, and let's say this is your server. Okay. So, server. Okay. So let's say this is your server, and the IP address of this server could be like uh, let's say 172.16.3.10. Okay. And you are coming from internet, and let's say this public IP address is maybe 100.100.100.10. Okay. Now, if you come from the internet and try to access, so this is like publicly accessible web server that I have hosted in my DMZ. Okay. And when you try to access this, so you will not have this private IP address, right? If you are a user on the internet, you will not have the private IP address. You'll always have the public IP address. Okay. And when you try to access the resource which is there in your DMZ, you will enter. So there might be some FQD, and I'm just simply considering the IP address for the sake of simplicity. So 100.100.10, you try to access that 100.100.10 on your browser. Okay. So once you do that, you'll be hitting this interface of the PaloAlto. Once you hit this particular interface of the PaloAlto firewall, this firewall is going to do a destination NAT. Okay. Now, if you see, the original packet arrived on outside and the destination was also outside, right? So, pre-NAT, when we talk about pre-NAT, the zones were outside. This is my source zone and my destination zone. My destination was also outside, right? The traffic originated from outside. The traffic is coming from untrust, or sorry, my bad. I should use untrust. I should not use outside. So the source zone is untrust and the destination zone is untrust, right? Because the packet came from untrust zone. So this is where the traffic is coming from, right? And the destination zone again is this interface 10 100.100.100.10 is in untrust zone itself, right? So the traffic that you see coming from untrust going to untrust, right? But post NAT, this will change. This will change from untrust will be your source. So my source zone remains the same, but my destination zone will change to DMZ, right? Now you need to have a security rule that would allow the flow, this flow from untrust to DMZ. That is the reason the post NAT zone should be allowed, right? If you allow untrust to untrust under a security policy, this traffic is never going to reach your server. So you'll be able to hit the public IP, but that even if we do the DNAT, we'll not be able to reach this because there is no security rule that is allowing that flow. Okay, this might be a bit complicated, as I mentioned in the beginning. Uh, let's not jump too much into this. Just for the information, just I wanted to clarify this point where we say post NAT zone should be allowed. This is because of this, that always when you talk about security rules, think about post NAT zones. Okay, when we are talking about zones, it will be post NAT zones. When we are talking about IP addresses, it will be pre NAT IP addresses. Okay, cool. I know there will be a lot of questions on this. We'll discuss about those towards the end. uh, we'll talk about this towards the end. Okay, cool. All right. So we saw. the traffic heading towards the internet getting uh, source NATed by our NAT rule that we have configured default NAT, right? And the IP address for the source IP was modified, but the destination IP remained the same. So the destination remained the destination remained unchanged, right? So it was still heading towards the untrust. Okay, so the security rule allow internet, source is trust, destination is untrust, and the action is allow. Always remember, for if whatever traffic you are natting, there should be a security rule that should allow that flow. Otherwise, your packet will not leave the firewall. Okay, your your packets will get dropped if there is no security rule that will be allowing that flow. Okay, so this was about DIPP, where we modify. Now, what is the significance of DIPP? DIPP is like, as I mentioned, it's a path. What will happen is, if you have hundreds of machines, right? Let's say machine 1, 200, right? And these are connected to your switch and then connected to your PaloAlto firewall. This is your trust interface. Okay. Now we are doing a NAT for this particular untrust interface. We are doing a source NAT. Okay. So SNAT DIPP, right? And this is my internet. This is my Ethernet 1/1. This is my Ethernet 1/3, right? So what will happen is, all these private IP addresses 172.16.1.2 till 172.16.1.100, all these IP addresses are gonna source NATed to the untrust IP address, right? So even if the packet is coming from 172.16.1.2, or if it is coming from 172.16.1.100, my source IP is going to be, after natting, okay, post nat, the source IP is going to be 10.1.1.2, but my port, or rather source port, my source port will change. Okay. Now, this entry will be maintained on the PaloAlto firewall. So whenever there is a return traffic, that return traffic will be allowed, and the natting will be done based on these entries, right? So the source port will for example, the source port. Okay, let's draw the table. So mm, let me draw the table itself. That simplifies it. Okay. So let's say pre-nat and then post-nat. Source IP, let's say destination IP. Source IP, source port, and then destination. Similarly, source IP, source port, and then destination. Okay. Now let's say the source IP that is coming from 172.16.1.2, and the source port was, let's say, 28,000, because it is random. Okay. And the destination is like 8888. Okay. Once we do the postnet, the IP address will change 10.1.1.2, and the source port will also be changed. It will be something, let's say, 35,000. Okay. And the destination is going to be same, 8.8.8.8. Okay. When, let's say, 172.16.1.10 It's coming on port 29,000. Destination is A.A.A.8. The source IP is going to be modified to 10.1.1.2. However, the port number will be 35,001. See, these port number examples that I'm taking, these are random. Uh, Again, this could be anything that is taken by the firewall by its own logic. Okay, so this is just for the explanation. Don't think that it will take 35,000 all the time. Okay, and the destination is going to be the same. Okay, if it is come from 172.16.1.100 and it's coming on, let's say, 31,000 and 8.8.8.8 and 10.1.1.2, this will be like 35,010, whatever, right? A.A.A.8. Now you see the difference. I mean, what we are doing, we are just modifying the source IP address to the source IP address of the interface over here. And then we are also modifying the source port, right? And based on this, so this entry will be present on the firewall that what changes were done with the original packet. And once the return traffic comes back, it will do a mirror match of this traffic. Uh, so the reverse, like for example, the source IP from then will be the 888. The reply will have the source IP as 888, and the destination IP will be 10.1.1.2, let's say 35,000. So for 35,000, we have modified this particular packet, right? So it will do the denatting of it. It will translate it back to 172.16.1.2, and the source port will be 28,000, right? Whatever changes we have done, and then will be sent back to uh, the machine, right? So the first machine. So this simplifies it, right? Having the table, I guess I'm able to explain it to you, or I mean, we'll see if there are any other questions towards the end. Uh, so this NAT table will be there. Based on this, all the entries will be maintained, and whenever there is a return traffic, it will be translated back to the and sent back to the original machine. Okay. Cool. So this was about DIPP. DIPP, again, there is a option of translated address. We'll talk about, we'll understand that from the second perspective. The second option, it's almost similar to that, just a minor difference. Okay. So if you see the translated packet again, so DIPP, this is just what we discussed, dynamic IP and port. Dynamic IP, if you select dynamic IP, what happens? See, for dynamic IP and port, if you selected dynamic IP and port, you had address type. There were two options over here. One is translated address, and the other one is your interface address. Okay. If and then we have selected interface address because we are natting the traffic to the interface Ethernet 1/1 and the IP address. Now, if you go ahead and change it to dynamic IP, you see there is no other option. It just gives you a translated address. Now, what do we have to add over here? Translated address. The translated address should be having a block of IP address, or see, you can have a pool of IP addresses. Okay, that will be used to translate uh, the source IP over here, because we are doing a source IP source NAT, right? So what I can do over here is assign an IP address, let's say 10.1.1.3. This will be my first IP address. 10.1.1.4, this will be my second IP address. 10.1.1.5, this will be my second IP address. Okay, third IP address. So let's say I have defined these three translated addresses. Now what should happen? What will happen is this will be able to help only three client machines. Okay, let's go back to the diagram. So let's say now you have 100 machines over here, right? There are 100 machines that are there in your LAN environment, and you have defined. Now we are talking about the dynamic IP source NAT. Okay, so in the dynamic IP source NAT, it will give you a block. It will give you a space to enter the translated addresses. Okay, translated addresses wherein you can enter the IP addresses, like address number 1 will be 10.1.1.3, address number 2 10.1.1.4, address number 3, 10.1.1.5. You can either specify individual IP addresses, or you can specify a block like 10.1.1.0/24. Okay, this is also possible, but it depends on what kind of arrangement you have, what kind of IP addresses you have for your NAT pool. Okay, if you have like a few IP addresses, then you can go ahead and list them like this, individual IPs. Or if you have like a block or a subnet, you can just mention the uh, 10.1.1.0/24 or something like that, right? You can mention in the subnet format. Okay, now what will happen is, once, let's say there are 100 client machines in your LAN environment, right? And each of them is trying to reach out to the internet, and you are applying them to, you're subjecting them to the source NAT using dynamic IP. Okay. And in dynamic IP, you have just added, let's say, three IP addresses. Okay. Now, based on these three IP addresses, what will happen? The first three client machines, okay, let's say, 172.16.1.2, 1.3, 1.4. So there were three requests that arrived on your firewall for the natting. 10, and these were natted. So the first request, when it came, it was natted to 10.1.1.3. The second request, when it came from 1.3, it was natted to 10.1.1.4. And when the third request came from 1.4, it was natted to 10.1.1.5, right? So the NAT addresses, now if you see, the NAT address pool is exhausted. There is no more IP address over here. Okay. So when a request from 1.5 comes, what happens? Right? This packet will be dropped. Right? This packet will not be natted. This will be dropped until the transaction for this one is freed, or any one of them is freed, and there is an IP address available in the pool back. Okay. So you can have it puts a condition, right, that your NAT address pool should be large enough to accommodate all the client machines which are there in your LAN environment. Okay. So if it is not, then you might see that some of the packets are getting dropped because of NAT pool exhaustion, right? So that is what is the dynamic IP. So again, it will be sort of like one to one, but again, it depends on the IP address pool, how many client machines will be able to reach out to their destination based on the IP addresses available in the NAT pool. Okay. Okay. So this is about dynamic IP SNAT. Generally, I mean, there might be certain use cases when you have to use this, right? But I haven't seen this more in the environment. The most common one is the DIPP or the PAT that you'll be able to see in corporate environments. All right. Uh, one important thing is we do not touch port over here. Okay, so there is no changes to the port. You can see it is just dynamic IP SNAT. So we are just changing the IP addresses, because of which we are not able to do a lot many client. If you talk about this one, so you can see DIPP 100 IPs, even if you have 100 clients, they can use the same IP address and reach out to the internet, because the ports are changed, right? So we are doing a port overloading over there. Okay, there is no port overloading over here. So dynamic IP source NAT is sort of like restricted. Uh, there might be use cases. That use cases might be complicated. If I discuss them right now, you might have certain internal web servers or internal any servers for which you'd like to do this. But again, it could be like different requirement for a different organization, right? All right. So this is how you can configure the dynamic IP. If you would like, we can go ahead and do a commit. I'm just adding this IP address as 10.1.1.3. Click on OK. Let's do a commit. So far, the traffic that was going out to the internet was using your 10.1.1.2 interface and IP address, right? So if you see, this is the traffic that is headed towards the internet. Allow it a minute. So you can see interface 1/1, and we were using the IP address as 10.1.1.2, right? So the natting was done for using the interface IP address of 10.1.1.2. Right now, we have configured a NAT rule with the translated IP address, or we have provided the translated address as 10.1.1.3. Okay, we'll just see that in action. Okay, let's see if the commit is successful. It's almost done. Okay, the commit is complete, successful. Let's have a look at, let's try to initiate some traffic. Okay, let's do the google.com. Let's try some Facebook as well. Cool. Let's go back to the firewall. Let's see the traffic logs. Let me refresh this. Taking a minute, guys. Just allow it some time. So now you can see, these are the DNS queries when we open the google.com or the facebook.com, right? So it's reaching out to 888. uh, Even these DNS queries are getting natted to, now you can see 10.1.1.3, right? And you can see the port number is same, 61839, 61839. We are not doing any modifications to the port. It's just the IP address that is being used. Now if I have like two machines running at the same time, the packet for the second machine would be dropped, because until the transaction for first machine is completed, right? So you need to have enough IP addresses in the pool so that all the client machines would be able to access the resources at the same time, right? So that puts a pretty big or huge restriction, I would say. That's the reason DIPP is used mostly, unless there is a certain specific use case to use the dynamic IP. Okay. Uh, let's discuss the last one. I think I have taken up too much time today. But no worries. Let's discuss the last one over here. The last one is your static NAT. Now, static NAT is nothing, but it's a one-to-one mapping. One-to-one mapping. Okay. The You can say it's similar to dynamic IP. The only difference is, we have just one IP address to specify over there. Let's go and have a look at that. Let's come down. If you select this as static IP, you'll just have an option to specify one IP address over here. That's it. You don't have a pool of IP address that you specify in case of dynamic IP, right? And again, this is one-to-one mapping. This could be like, uh, just it applies again. There will be only one uh, machine that will be able to use it. You can specify a pool that. Okay, let me go back to the whiteboard. So when we say one-to-one mapping, you can use this, let's say 10.1.3. You have just 10.1.1.3, right? And then there is one client machine 172.16.1. 3, right? You would always want this machine to have this particular IP address while it's leaving out to the internet. In that case, you're going to go ahead and configure this as static NAT. Okay. This will always be one mapping. You'll not see any other mapping for static NAT. On top of it, you have an option to select that as bidirectional, right? When you select bidirectional, this applies to both the traffic. Now, when we say both the traffic is whenever there is a traffic which is originating from someplace else and is headed towards 172.16.1.3. For example, let's say there is a traffic coming from 8.8.8. It originated from 8.8.8 and then it is headed towards 172.16.1.3, right? Even in that case, this static NAT would come into picture, and then sorry, 10.1.1.3, my bad, once again. 10.1.1.3, right? So if there is a traffic coming from 888 to 10113, even in that case, this static NAT will take a hit and then translate it to 172.16.123, right? That is why this is called as static NAT. It will always do one-to-one mapping. We have a use case for this. If again, if there are particular servers that you'd like to access from a particular IP address, in that case, you can go ahead and configure the static NATs. Okay. uh, you'll have to provide a translated address. Again, you can do 10.1.1. Let's say, let's assign the same IP address, 10.1.1.3, and I'll uncheck bidirectional, not needed because I don't have any other machines out there, or maybe let this be checked. We'll see if we can test it from the router. Click on OK, click on commit. Allow it a minute to commit. Okay. We have assigned a source IP address. Let me 1 second. One second, guys. The commit is failing for some reason. Allow me a minute, guys. I mean, this is. No, guys. It was failing because we did not. So what happened is, I told you, right? It is one-to-one mapping, right? We need to specify a source address. So we modified the translated packet, but we did not modify the original packet, right? So we continued with the flow. We did not change the source address, right? One-to-one mapping means always it will take one IP address and will NAT it to one destination, right? So you see, we have added this original packet that is 172.16.1.2. That will always be this particular Windows machine, right? Our LAN machine, this one. And it will always NAT it to 10.1.1.3. Okay, now it is successful. Now the reason it was failing was because it is one-to-one mapping. It is not many to one, right? When you select any, then it becomes sort of like many to one mapping, and that is not supported. Okay, so the reason it failed is you need to specify a source address in order for the static IP to be static IP NAT translations to be functional. Okay, let's click on bidirectional for this time, and let's do the commit again. Okay, we can leave this bi-directional thing. No worries. We can go ahead and validate now. Are we able to access the internet or not? Right. Let's see. YouTube.com. Okay. Gmail.com. Right. So we are able to access the internet. That signifies this NAT should be taking a hit, but let's validate. So let's head to the traffic logs, monitor, and let's see if there are new logs. Allow it a minute. Yeah, there we go. Now, if we see this, give it a minute, guys. It's still loading. Okay. Now, you can see Gmail base, right? So we access the Gmail after the NAT rule was changed to static IP. Okay. And you can see the IP address is now changed to 10.1.1.3. And then the port is 49774, 49774. So even in the case of static IP address, we do not touch the port, right? Static IP address and dynamic IP. So static IP NAT and dynamic IP NAT are similar with the difference wherein dynamic IP NAT will have a pool of IP addresses. Static IP NAT will only have a single IP address based on which you can NAT one individual IP address to a particular IP address that we specify under static IP. For example, in our case, 172.16.1.2 will be NATed to 10.1.1.3, right? So that's how your static NAT, and it will always be the same case. Now, once I select bidirectional, in that case, whenever there is a traffic coming from the other side, which is to be sent to 172.16.1.3, then the NAT will still the NAT will take care. the same NAT rule will take care of it, right? So bidirectional means in both the directions, right? So whenever there is a traffic originating from 172.16.1.3 and heading towards internet, it will translate it to 10.1.1.3. Whenever there is a traffic coming from internet heading towards 10.1.1.3, it will translate it back to 172.16.1.3. So that translation will always takes place in both the ways, for incoming traffic and outgoing traffic. Okay, so this is how your static NAT works, or static IP NAT. One important point that I'd like to mention is there is no order of preference over here. For example, if I have configured static NAT, so static NAT would take preference. No, no such preference is there. You should always configure your most specified rule, or most particular rules towards the top, and then general rules towards the end, right? So what happens is the specific rules will take a hit. Okay, so because it is a top-down approach, always the rules will be evaluated from a top-down approach. Okay, cool. So this was about the NAT translations. Let's see what uh, I think I took up too much time while trying to cover the NAT and demonstrations and all those things, right? We have completed dynamic NAT with port numbers, static NAT. However, I think application filter will need to longer than 10 minutes. We are almost 10:50 now. So I think we can continue these topics in the last two classes that we have, coming weekends. Okay. Let me stop sharing. Okay. One more thing, guys. You will be able to import, like I did in the beginning, wherein you will have that security policy and the NAT rule, and that default route and interface IP configurations already in place. You all you can go ahead and import config from here, right? It will ask you to log in, and then you can click on import, right? This is for lab 3. I'll mention this again. This is for lab 3, wherein you'll be able to see these logs, traffic logs, and all these details. In the lab 2, you might not be able to see your traffic logs. Okay, so you'll have to do this in your lab 3. Cool. Let me go ahead and stop recording.